Today in Algebra 1B we begin our conversation about polynomials and factoring in Chapter 9. And we are actually going to begin with naming and dealing with special vocabulary from Chapter 9, and also the idea of dealing with adding and subtracting. So this is going to be the focus of this first section. Now let's deal with some of the vocabulary first. First of all, on this list you can see that there are really three vocabulary words that we're going to deal with here. Monomial, polynomial, and degree. Polynomial is kind of like a general term. A general term, like if I were talking about professional football, polynomial would kind of be a word like that. It talks about and covers lots of different pieces that will fit with it. Basically, a polynomial is either a term or one set of a number and a letter, a variable, or it may describe several of them that may be hooked together by add and subtract, like this one. Now, a monomial is a specific name. So we were talking about polynomials being kind of the professional football teams. Monomial would be the name of one team. So a monomial is an expression that is just a number or a letter, has just one term to it. So in dealing with this, there's also this idea of degree. Degree has to do with the highest exponent. So the highest exponent in this one is 2, so it has a degree of 2. This one right here, the 7, doesn't have any variable at all with them, so it has a degree of 0. Some people actually like to pretend there's almost like an x to the 0 in that spot. If there was, you can see that the 0 would be the 0 that you get for degree. Now, you don't have to write this here, but it is something to kind of keep in mind. Now, in this kind of a term, there are multiple things going on. And if I were to look at this, 4 times x squared times y squared, those are all things that are multiplied together. So in order to figure out the degree, we take the exponents of all of the variables and add them together. So if we were to take that 2 and 2 and add it together, that's where this 4 comes from. Now, being able to know the degree is going to help us later on when we have to name things, and also when we have to put things in the kind of order that they want us to. So let's first of all talk about order. When I talk about this idea about standard form, first of all, this is another vocabulary word. It's also something they're going to use a great deal in Chapter 9. To be able to deal with standard form, it's to be able to take whatever kind of expression you have and be able to put it in order from largest exponent. So in this one, 3 is the largest exponent, and I would work my way down. So 2, now there isn't 1 here, which means that I probably have an exponent of 1. And then down here I don't have anything at all. Now you can think like we did the last one, that this would be like x to the 0. Or you can just remember that a number that stands by itself is the last number that's there. It's considered a constant. Now, to be able to name things, we're going to have to use an idea of degree and then term. So if I were doing that, one of the things that I would want to consider is that the first name of this is going to come from our degree. Okay, now when I'm talking about first name, it's like a person. If I name somebody by their last name, unless it was a very unusual last name, knowing their first name would narrow down a whole lot more information about who you're thinking about and what you're doing. The last name here is going to come from the number of terms that are there. So if I go through this one that's here, the highest exponent in this one would be an exponent of 1, which is not written out because that's one that we assume there. And so that means that its first name is going to be linear. And then if I look at this, there are 2 terms. The 7x is one term and the plus 4 is another. Can't put them together any more than already is written there. So its last name is going to be binomial. In this one right here, the highest exponent that I have is 2. So its first name is going to be quadratic. Anything that had the first name or had an exponent of 2 as the highest exponent would have the same first name of quadratic. This happens to have 3 terms. So it's going to be a trinomial. Remember, we talked a little bit about prefixes today in class, where mono talks about 1, bi talks about 2, Try talks about 3. And then that poly is going to be really anything that's more than 4. So kind of keep that in mind. Now in this one, the highest exponent is 3. So its first name is going to be cubic. There's only one term here, so it's going to be mononomial. That means that physically this one would be called a cubic mononomial. Now in this one, highest degree is 4. Now we have special names for anything under 3. You know, you can see here linear, quadratic, cubic. Those all have specific names. Anytime you get to 4 or larger as far as your degree, you're just going to call it the 4th degree. If the highest exponent over here was 10, it would be the 10th degree. If it were 8, it'd be the 8th degree. So you just have to know that anything that's 4 or larger is just going to use this kind of format. Also, this has 2 terms, which means this is going to be a binomial. Now in this last one, this is 5. And there's no variable that goes with it at all. So first of all, we could think about it like this. You know, that x to the 0 again. But they call this constant. Anything that doesn't have a variable is considered to have a first name of constant. And this is mononomial because it has one thing. So this is where the mononomial comes from. So naming things is going to be a big idea later on. Okay, let's go on to adding. Now in adding, I'm going to go through and do something similar to what you did probably when you were in elementary school. If I had to add 2 things together that looked like this, in order to solve it, if I were doing it by hand, I would actually line up my things so that the things that belong together were in the same columns. We are actually going to use the same kind of idea in this one, except we're going to do this with our variables. So if I look at this list, the highest exponent I have is x squared. Now that means if I went in standard form, the next thing would be x, and the next thing would be a number. So what I'm doing is I'm really just making columns. And I'm going to take this first one, and I'm going to sort it into columns. So my x squared would go here, plus 6x is here, and then plus 7 is here. Now I'm going to do the same thing with this set. So 2x squared would go here, minus 9x would go here, and plus 1 would go here. This is just like a big sorting problem. So I'm going to add 1, draw a line, and now I'm just going to total my column. So this would be a plus 8, this would be a negative 3x, and this would be 6x squared. Now on this one, this is going to be your final answer. Okay, let's do the same kind of thing over here. This one, the highest exponent out of anything would be x cubed. So it's going to be x cubed, x squared, x, and a number. And now I'm going to start by just sorting my stuff. So if I sort my stuff, I have 5x cubed plus 3x squared plus 7. No x, so that's actually left blank. And then I have x cubed and then 4x plus 10. So I'm going to draw a line here. Now, a couple things I should probably add in. 1's in this spot, and I would also add 0's here, just because there's nothing there, just to kind of give you a good visual reminder. So this is going to be 6x squared, or x cubed, excuse me, plus 3x squared, plus 4x, plus 17. And this is going to be our final answer. So the columns give you a plan of how to go about a problem. It also gives you very direct information about what you need to do and how you need to set it up. So just something to remember. Okay, last thing I want to talk about is subtraction. Now we set up our columns in the same way. So in a problem like this, I would make columns that would be x cubed, x squared, x, and my number. So I'm going to sort these just like I normally would if it were an addition problem. So it would be 2x cubed plus 5x squared minus 3x. Nothing to put in the column for just numbers. If I did the next one, it would be x cubed minus 8x squared and then plus 11. Now, if this is subtraction, probably a couple things I need to think about is that when I subtract things, it's really like adding the opposite. So I need to go through this list right here and do the opposite of all the numbers. So this is going to be a negative, and actually I'm going to add a 1 there. This subtraction is going to be a positive, and this is going to be a negative. So you have to do the opposite of all the ones that are come after the subtraction sign, which would be everything that's in this one. Now I'm going to add my zeros right in here, and then I'm going to total my columns. So 1x cubed plus 13x squared minus 3x minus 11. So in this kind of a problem, it's going to be important for us to get those organized. Remember, you probably won't see a 1 written here if you were to see it on a test. So you're more than likely going to see something that looks like that when you go to organize it. So there's our final answer. Okay, let's try this last one here. On this last one, v cubed would be the highest exponent. So if I go to set these up, my problem looks like this. Now remember, first time through, just go ahead and sort it. So v cubed plus 6v squared minus v. No number here to put anywhere. Now I'm going to go to the next one. 9v cubed minus 7v squared plus 3v. Now remember, if it's subtraction, I want to go through and take the opposite of every single thing that's here. And then I'm going to also add 1s. Now my job is just to total it up. So negative 8v cubed plus 13v squared minus 4v. Now remember, the big idea with subtraction is anything that's after here, you have to change the sign. So you have to make sure that that happens here. And you are still adding these things together. But you can't do the adding piece until you go through and change all the signs. So that means on this one, your final answer would be this.